a combined microphone, 2-in-1, because one is for streaming online and the second is so that you can hear us better. So we came up with a very good integration solution last minute, and this is not the first time we do it, to be honest. Alternative was to buy like a fancy mixer audio and have it somewhere, but hey, sometimes we are Python developers, for God's sake, right? Works. Okay, do we have the stream? Not yet. Good. Before we go to the stream, then, we have a couple of announcements that I can go through. Announcement number 1 is one very special event that we are doing in January. So, to introduce it properly, who is here the first time today? All right, I love this. It's always a half of new joiners. Amazing. This is the first time. It's probably not the last time, though. We do our best for that. Good. So do we have any veterans who have been here for more than 3 years ago? Anyone? Okay, maybe. Then these veterans might know what is PyCon Web Conference. Or maybe not. All right. Oh, yes, they do. So we had a conference. In addition to the meetup, we had a conference here in Munich. It's the same community, the same thing, but like 2 days event, 3 tracks, big one. And then COVID came and it died. Well, like many nice things. And then COVID left and we thought it's time to bring it back. And this is what we're doing end of January. It's risky as hell because it's less than 3 months to go. It's 24th, 25th of January. And it's in Berlin, making it even harder. But because PyCon Germany was in Berlin, it just makes sense to make a big event there because now PyCon Germany leaves, the stage is empty, and we are taking that place, hopefully. So if you are subscribed to our meetup group, or you can also subscribe to our Twitter page or to my personal LinkedIn, we will be sharing the discounts for community. They are always bigger because the community is what built this conference in the first place. So this is not a marketing stunt. This is the real thing. We will be sharing really good conditions, and it's community-driven anyway. CFP is open. There is democracy. Suggest a good talk, and you will be there, invited. And I will personally bring you a carpet to the stage because I like when people get involved and come back. So do we have the stream, Mr. Eugene?
Yes, we have, but the problem with camera.
Problem with camera. Okay, we can use the phone then. Good. So for those here the first time, it's really going simple. Like we have Q&A after each talk. After the first talk, we'll have a break for like 15 or 20 minutes, something like that. Because we have live streaming, we have to be disciplined about the breaks and timing because people online are also joining. Like it's our own fault. We started this streaming thing when COVID started. So now we have a community also online, and we have to care of them, and we love them. So we try to stick with the timing. So there will be like 15 minutes break. Please grab some drinks, get to know each other, because in the best case, after leaving from here, your LinkedIn should be exploding with new invitations. So at least, yeah, I will do my best. I will catch everybody of you. And that's like an introvert way to get to know people. An extrovert way is just talk about Python, about anything. And very important, talk with us. Give us feedback and suggest maybe your talk for next meetup because we desperately need speakers. We are running this thing now every month for like a year, and every month we have 2 or 3 speakers. We're really running out of speakers here in Munich. So really highly appreciate it if somebody steps in. And we have a list where we put you, and there is really no casting. We help you to shape your topic in some way, to make it more beginner-oriented and more community-friendly, and you'll probably be on this stage in 2 months or so. Good. So I guess now we should be starting. I see us in this image, which means we are right in perfect timing. Good. Very nice. Good. So now you can put this like full screen because we have no slides for the introduction. Okay. I think everybody is in, and yeah, almost. Yulia is not in. Yulia, faster, faster, run, run, run. Oh, please, we are waiting for you now. The whole audience. Please make some applause for Yulia. Look how shy. That's a bad example. Please, yeah, make her less shy, okay? Good, then we're done, and without further ado, this is Philip. from Synvert Insights, whom we are very thankful for hosting us today, and we are very thrilled to learn something about the company. Warm welcome, please.
Yeah, hello and welcome. My name is Philip. I'm a senior data scientist at Synvert Data Insights. We are an international IT consultancy, and we are all about data, bringing ideas into production, and you will learn a little bit more about that. If you find
which will expose this hardware on, say, HTTP protocol? That's the question I want to address. And I will be showing, of course, when I say simple Pythonic IoT or data acquisition, I would also like to emphasize on using HTTP and JSON data format, and maybe some object-oriented code for this. So before you start writing your server, you might want to ask the question, how to abstract my interaction with the hardware? So there are three basic ways you can divide. There may be others, but this is what I use. So one is properties, one is actions, one is events. So say you have a camera like this, maybe you see something. So you have a camera. Properties are just typed. They are typed get set values. So you have a read and write for this value. So if you have, say, camera exposure time. So the exposure time of a camera is a number. You can read it and you can write it from the hardware. So same thing with frames per second or FPS. So you can set the FPS and you can read the FPS from the camera. Or if you have an image, you can just read the image from the camera, but you cannot set it. So because the image comes from the hardware. So these are properties. Next is actions. Actions means you command your hardware to do something. Say start measurement or start video, snap an image, stop video, update your information, something like that. So finally, events. Events tell a client what happened on the server without the client asking for it. So for example, let's say you have a camera. So I have a camera here as well. So you do a long exposure snap, say 5 seconds. You're capturing a video that takes at least 5 seconds. So then you want to know when has my image finished capturing. So you can say, okay, an image is available. I did a snap action, then an image is available. So this you can push as an event. Similarly, we do scientific devices, so sometimes we want to know how hot the device is and so on. So if, say, camera overheated, so you can send an alarm to a client, okay, it's heating up. And this abstraction is proposed by what is called as Web of Things. It's an upcoming W3C or World Wide Web Consortium standard. They propose to divide the hardware interactions like this. And these abstractions are independent of what protocol you use and what serialization you use. So as I said, I will be showing something with HTTP and JSON, but it doesn't matter. You can use pickle serialization, or you can use some other protocol like ZMQ, or that's something called MQTT. So you can use any protocol, any serialization or data format. So it doesn't depend on that. Finally, what you may find useful sometimes is a state machine. So state machine says, okay, if a camera is capturing video, don't change the exposure time, because the capture is going on, so it will interrupt the image capture. So, or you can say, okay, I'm already capturing some video, then don't let the user to snap an image. So it doesn't make sense, right? So that this you can achieve with a state machine. Finally, if as I said, I want supposed to be beginner friendly. So I will show some OOPs or object-oriented code for this. So firstly, so this is a Python package I've released on pip. It's called hololinked. It means you can put your device on the internet. So you can just create a class. So camera class. This is from this company called IDS, or IDS Imaging GmbH. So they have this UI camera model. So that's the class name, and you have to subclass from the thing class which I provide. Then you can have some functions which get and set values. Means if you want to model properties, you want to write a get and set function. So within the get and set function or method, you have to write the device driver code. Sorry. Yeah, sorry, it's just like, okay, yeah. You have to write the device driver code that will write the data to the hardware. So this will be something you write on the wire. Say I have USB here. So this thing writes the value into the USB to the camera. So that's what you write. That's your job. But say you have get and set function, and you just define what these functions mean. So to put it on the network, you can just define this descriptor. Actually, some of you may know about descriptors in Python. So descriptors give a get, set, and delete function built in the sense, if you supply a get, set, delete, what you can do is, I'm sorry, can you remove this? Yeah. You can say you instantiate the camera like this, and you can use this dot operator to read and also to write with the equal to sign. So that will automatically invoke the fget and fset. And this other things like bounds and unit, talk, these are just metadata as to what the property means. So you might want to keep this because, say, exposure can't be less than 0. So you have to validate the data also. So that's why this extra metadata is important. So to already expose this on the HTTP protocol, what you can do is just instantiate the class. You can give an instance name or an ID. The instance name is just the ID of the camera or your device. And just run its HTTP server and the port. So this will just put your device on the HTTP server, and you can invoke this. You can invoke this property with get request method for reading the property, put request method for writing the property, and delete for deleting the property. So if you have no deleter, which usually is the case for hardware, so you just get a 404. So next is actions. If you want to write actions, you can just use this decorator called action. Again, you have to write the device driver code. So you have to command the hardware, okay, start capturing images. That looks something like this. It doesn't matter what it looks like. And if you are using some arguments for your actions, you can specify some JSON schema, how to validate these arguments from a client. And actions are invoked with the HTTP post request. Again, just start the device and the server gives. If you want some other client, so I have the ZMQ client. In ZMQ client, you can just specify the instance name of this, whatever the server is, and you can directly invoke the action on the client as well. So as I said, it doesn't depend on the protocol. You can use HTTP or you can use ZMQ or whatever you feel comfortable. Finally, for events, let's say you have doing a long exposure snap. So if you define this event object gives pops up. It gives a pops up object. So pops up objects have they have a publisher, and your subscribers can subscribe to the event, and they can register a callback, which will be called when the event arrives. So let's say you start the video, you're running your snap method, you start the video, you get the next image, you encode the image as a JPEG, and then you tell your client that, okay, I have finished capturing. So the timestamp was this time, and the size of the image was so much. So these are some ways of using the events. And finally, for the state machine, again, it's an object. You can specify what the initial states are. So let's say you have a camera is on, have it on USB. So I can disconnect it. If it's disconnected, you can put it in disconnect state. And if you connected it, you can put it in on state. And if you're capturing a video, you put it in capture state. And if you had some problems while the code had some exception, you can put it in false state. You can just specify the state machine and the initial state of the state machine. And you can say that in disconnected state, only allow the camera to connect. So the connect will be in action. So it doesn't make sense that I start the video when I'm disconnected state. So that's why it's, if you make a call, if you make an action request from a HTTP client, it will just raise an error that, okay, this won't work. Same thing with, again, on state and capture state. So you have to do mutually exclusive actions if you want. If you don't want, you can just ignore the state machine. You can also specify states like directly in the properties or in the actions also. So let's say the exposure time can be set only in the on and capture state, which means when the camera is capturing, I may be able to change the exposure time, but it depends on what you want. So if you have some action or a property which has to run in multiple states, you can specify directly in the directly on the property or the action also. So how you can use a state machine is when you run the action or any method or any Python method, or it can be any Python logic. It doesn't have to be just what you expose on the network. You can just set the state machine state before you do the operation. So I'm starting my video here, capturing an image. So before that, I set the state to capture, and if I had some exception, I put it to fault. If I don't have, then I put it back to on state. So this is how you can write an object which can expose a hardware on the network. Maybe I'll just show some small example. What I have here, can you see my, yeah. So this is the camera. So I have it again here. Can put it, so I can click start measurement. This is again what I have in the first row, like reset fault, snap, start acquisition, stop acquisition. They're all actions. And this FPS you can set here. This is the exposure time, that's the gain. These are all properties, they have different types. So for example, exposure has this they have number type. So hardware trigger is a Boolean type. And image itself is a property, it's a bytes or it's an encoded type. And here I have this also called show raw. Show raw means I'm just fetching the raw PNG image through NumPy. So that means it will be a list type. Or you can even have a NumPy type, it's possible. If I just, yeah, I hope it's working. So this is a GUI you can write in, yeah, 1 second. Yeah.
I wanted this. Sorry.
So I mostly write GUIs with this because we write for scientific, as I said, we customize our data acquisition to our needs. So our GUIs are written by ourselves. Our say we want to store the image. I have this thing called I have some image storing functions also here. So that's specific to experiment, but you can. So these are written by us to do the data acquisition the way that we want. You can also, as I said, do simultaneously over HTTP client as well. Let me just open this. So this is, I have this stage here behind, and this is PyQt client, and that's a JavaScript client. So yeah, for example, these are all properties. So let's say position. So this is the position read value. So that's a current position. This is a position I want to set. And this is a relative movement, which means move relative left or right side. So again, you can, irrespective of protocol, you can again have the same value here. This is a property, and these are actions. They model, they invoke actions on the server. So I can move it, let's say, right now it's to 20, I can just move it to, let's say 5. So what you can also see is if I change the position, if I give a command here, it will also get reflected here. So, so how to do that, I will just say next. Again, irrespective of whatever, you may buy any device from any vendor. They may even give you some, say, a binding that will expose it on a certain protocol. If you just divide your interactions in this way, irrespective of protocol, you can have the same interactions in different GUI frameworks or any script you have written for this purpose. So again, yeah, I can go here, maybe just. I'm not to the sorry. Same thing. Yeah. So that's what I wanted to show. Thank you. So especially the JavaScript side, again, you may be interested, if you're really into IoT, you may be interested in having these things interoperable. So I buy different devices from different manufacturers, how everybody's giving their own protocol, how to make them interoperable. This Web of Things, they suggest to use what is called as this thing description. So this thing description is it's a linked data JSON document. And what it contains, and I'm not an expert in semantic web and linked data, I'm just a hardware guy, but I'll just tell what I understand. So this description has a textual metadata about the thing. So thing is just the hardware. So it can be anything, your light bulb or your solar panel, energy meter, whatever it is. So it has firstly some textual metadata about the thing, and it has then it shows the available interactions, which are the properties, actions, and events, and some data exchange format. So I have a number, I have a big JSON. Properties can themselves be JSON files or JSON documents, or it's a string, it's an image. So these are data exchange schemas. So what payload to write to write a property, and what payload to provide to invoke an action. So these are, or what you get as a output from an action. So these payloads are data exchange schemas. Finally, there is security definition. If you're really putting it on the internet, which I don't do, I do data acquisition, which means we are in local network. But HTTP means you can just make a gateway, just put it on the internet also. But you may want to have some security definitions, which means what cookie or what credentials do I need to provide. So they have like cookies and JSON Web Token. There are actually two more. There is this. Yeah, I'm not an expert. So, and you can further this thing description, again, it's a JSON document. You can link to other documents or other things, which you may running somewhere else. So I can link my camera to my stage by providing just a link in this document. It says it can mean that the camera is related to the stage somehow. That you have to interpret. Again, yeah. So this is how it looks like. JSON in JSON format. So these are the metadata. So what's the ID of my thing, and what's the title, which means what it is. You can say, okay, my motor or my camera, and who to call if you have a problem. When it was created, when it was modified, what version it is. So these are all the metadata about the things. So then you have the properties, actions, and events, which are the interactions with the hardware. Then you have the security definitions, how to access them. So let's say you wrote this property. Now I auto-generate this for you. So you get this description of what the property is. So for example, you said the exposure time for image in milliseconds. So that will be fit here. You said that, okay, the unit is milliseconds, which means the exposure is in milliseconds. And it's a number. Again, it can be an object, it can be a JPEG image, whatever. And let's say the bounds it has to be minimum 0, but not 0. It has to be greater than 0. So that means exclusive minimum it's an exclusive minimum, and it's above that. And get and set is what you invoke from a client. So let's say these are specified in what is called as this forms field. The forms field tell what it actually means is what data do I have to submit where to invoke what. So for example, to perform what operation. So let's say the operation is read property. So the endpoint must be your domain, your camera name or instance name, and the name of the property. So I can auto-generate this for you. Actually, you can even supply the URL path. You can supply I even let you change this, but it's suggested to use get HTTP method. So this is the HTTP method name. And what's the content type? If I read the exposure time, I get a JSON value of the number. So similarly for for write property, so make a put request at this same endpoint with content type application or JSON to do write property with a JSON payload which has the value of the exposure. So there is also something called observability. So observability means I change a value, all the clients get informed what has changed, how much has changed, what is the new value of the change. So that's the observable. So I showed the position where it changes in 2 clients. So that's because the position is observable. And how to observe is, again, give the whatever the endpoint. I have this default change event endpoint, and the operation is observe property, and you have to make a get request at this endpoint, and the content type must be text plain, or actually it has to be text plain for, in this case, for Web of Things standards, it's somehow like that. When you write the HTTP server, you usually use text event stream header for this, but the content itself is just text. And the sub protocol is SSE, means it goes as a server sent event. So the client only has to initiate an event source. You get changes, or whenever events are sent, so it will be sent with this SSE sub protocol. So why you may want to know why to use this thing description or this JSON document. So one application can be, say, I have different properties. So again, this is one device we use. So say background subtraction, integration time. So each has some different types. So Boolean type, integration time is a number type, and this may be an enumeration type. So you can just parse the thing description or the property, whatever property description is, and you can auto-generate this GUI elements. So if I know it's a Boolean type, actually it's not visible there, but this is a checkbox actually here. So if it's a Boolean type, just put a checkbox. If it's a number type, give a field with a minimum value of 0 and give a send button. If it's read-only property, then you won't have a send button. And if you have any enumeration type, give the options to the user. So this is something you can do without the server, just by parsing the thing description or whatever the interactions are. You can just you can parse the description and auto-generate them. So that's the purpose of. Again, the domain can be anything. I do some web development, so I do these type of things. But your domain may be different, and your use case may be different. So that it's supposed to be both human readable and machine readable. So that's the whole point. And for observable properties, say you set the value. Say you set this integration time. So if you set it to the server just inform the value back to all the clients. So that's how you saw the different GUIs responding to the change in the values. So for actions, again, you can say how to invoke the action. So name of the camera, what's the action name or action endpoint. So the operation is invoke action, the HTTP method is post. So that this description says this will be how this action is invoked. And what is the payload necessary to invoke this action. And actually, one reason why to specify this payload is you can pre-validate the payload from the client also. So if you have a JSON schema validator, you can just pass this data schema to it and have your payload validated upfront before sending to the server. The server will also validate, but just saying. Finally, for events, form says how to interact. So subscribe event. So make a get request at this endpoint with and what you'll get is an event source with and it's a server sent event. So let's see. So these are auto-generated for you. You don't have to make it, but I just want to conceptually show what it is. Yeah, this data field is what's the payload you get for the events. So from this thing description, actually you can even make an entire client. So, and people have already done it. You can actually check this Thing Web project from Eclipse Foundation. They have like at least 5-7 protocols, and you can just apply thing description. It will make both servers and clients for you, irrespective of where you bought your hardware or what application domain you're doing. Yeah, thanks a lot. That's all. Any questions? Yeah.
Bravissimo. Questions. Even if you don't ask, I still see questions in your eyes. I will, yeah, I told you. You see, I knew it. Please pass the mic.
Hi, my name is Friday, God's will. My question to you is this: you did maybe I didn't catch it, but did you talk about any drivers, any hubs? Where is the camera connected to? Where is it going to?
And maybe I won't move the full screen. So say, let's leave the camera. Let's say the stage which I have. So I have a controller sitting right here. It's a little heavy. So that controller talks over serial or RS-232 or something like that. So it can also be Modbus. It can be, usually depends on, it can be even be some embedded level. If you use Raspberry Pi, you'll get some system level commands or code which you can write that. So that's what I meant by device driver. Is that what you want to know? Okay.
All right. More questions? No more questions. Not even Eugen. Not today. Okay. Oh yeah, one question.
Yeah, so thanks for the presentation. I just have a quick question because all of that looks like you have to know your stuff. Like, how's the developer experience using that?
Yeah, so Mike again.
You have time to think before microphone.
Speed up. Thank you. That's a hard question. So I think what I contribute to this is putting it on the HTTP protocol, at least that you can save. If you do it in, what to say, say you don't have something like what I have, say you just put together with your existing Python tools, like you take Tornado HTTP server, or you take the JSON serializer, you just existing tools. If you try to put it, it's going to be a little harder than just even this. So it's one step better than being even harder, but it can be hard. Actually, what I showed is more real time. I think you have to find some project like, for example, this, Arduino. You have to try from something small, then go step by step. I think that's one place where I can help, or where this thing helps you. So you can just start with this camera from Raspberry Pi or a moisture sensor. There are many of these embedded chips you get from Adafruit or many other suppliers that give you. But you have to know, you have to have a perspective of the physical world to develop this kind of software. Yes. Is that what you wanted to know?
How's the daily driving using that? Because for me, it looks like you have to know each parameter where to set it.
Yes, that you have to know, because that's the world of instrumentation. So instrumentation is pretty complicated, that so many electronics have very different types of ways of working, and there is no one answer to how to understand hardware. And so you have to know, for example, what a position means, or how much can I move, what's the limits. Actually, I do have, for this linear stage, it has 2 end switches, so one is not working. That's why I didn't move very much, because then I'll go and crash. So I have to know these things. So it's part of the job. But as I said, at least going from there to HTTP protocol is little easier with what I showed you. I won't say it's very easy, but it's easier than what I did like 4 or 5 years back. I had to literally stitch everything on my own for every single application. It was a nightmare for me.
Well done. I think that was the last question. We now have to go on the break. Do you have a PhD?
No, I did.
No, but I think we owe him one, right? This was a genius thing. So if we could, we would grant you. Big thanks to Vignesh. Big applause.
You can ask any questions now also.
Yeah, please grab him, make him prove his PyMunich PhD. I'll write down something in the break. So I have for you good news, a bit less good news, and good news again for the plan for today. Good news, today we have proper food, meaning proper warm food, not just some pizza. The less good news, the less good news is if we do it right now, we will probably need like at least half an hour. So we postpone it. Then the good news again is that as a workaround to like handle this next 10 minutes without starving, we have chips that we will put somewhere here, and we have that little boy over there with candy, who will gladly give you some, if didn't give you yet. Okay, so let's have a break, 5-10 minutes, something like that. Then the second talk about transforming Jupyter notebooks to web app, not some joke, okay? So I hope to see you. 5 minutes break. Well done, man.
Okay, thank you.
Get ready. Take your seats. At least let us see your beautiful faces. Time for the music to be stopped. So, our next speaker is Lynn from synvert Data Insights, who will be talking to us about heat planning and how to turn your Jupyter notebooks into web apps. Please, warm welcome for Lynn.
All right. So also a warm welcome from our side. Thank you guys for taking time out of your busy Tuesday to come here to join us. Thank you, Vignesh, for the very interesting presentation before, and thank you, Anton, and the whole PyMunich team for organizing such a great event. My name is Lin. This is my colleague, Alex. So I know in the invitation, it only said my name, but there are in fact two of us, and we'll be presenting the topic together. As you might have guessed from the name, and as Anton has mentioned, we're going to talk about a project we have worked on. It has something to do with converting Jupyter notebooks into Python web application, which I think many of you will be familiar with, at least conceptually. But it also has something to do with heat planning or municipal heat planning, which I'm guessing not many of you have dealt with before. So we're going to start with an introduction about the topic and go into the motivation of why we built the web application. We're going to go talk about the project a little bit, the steps we took, the architectural designs, and the technology choices we made. And hopefully we'll have time to look at a few code examples. And how you can use the same technology stack to build a Python-based web application of your choice. So to start with, I think I'll hand over to my colleague to introduce himself.
Yeah, thank you. Hi, I'm Alex, software developer since a bit above 10 years. At Data Insights since around 3 years, and into Python since well above 5 years, I guess. It's been a while. And yeah, thank you to be here.
Right. Well, my name is Lin. I studied industrial engineering and management in Karlsruhe at KIT. I graduated about 4 years ago, and I've been working here ever since at synvert Data Insights, as same as Alex, as the consultant in data science and data engineering. synvert Data Insights, as Philip has mentioned during the introduction, is an IT consultancy based right here in Munich, in this building actually. We were founded in 2016, and we've grown to about 50 people strong. However, 3 years ago, we have joined together with a few other companies, a few other consultancies to form the synvert group, which allowed us to expand our presence to cover many, many different locations in Europe, all over Europe, as well as the Middle East and the US. We have strong partnerships with a lot of the big technology vendors, AWS, Azure, Databricks, Ab initio, and Snowflake. And we offer services all around data, whether it's data warehousing, data strategy, how to automate data processing, building data pipelines, as well as everything to do with cloud, whether you're new to cloud, whether you want to move into the cloud, or you already have a strong presence, we can support you for that as well. And of course, in the area of AI analytics, as well as application development, which is sort of the core focus of Alex and I's work. So now, what is municipal heat planning? As many of you probably have heard in the news, Germany a few years ago has decided on the initiative called Energiewende, which is like in English translated, I guess, energy transition. The main goal of the initiative is pretty much to lead Germany into a greener climate future. So to become carbon neutral by the year 2045. and doing so, phasing out the usage of fossil fuels, expanding the usage of renewable energies, modernizing infrastructure such as the electrical grid, as well as the electrification of transportation. The whole initiative is split into 3 main areas, focusing on electricity, heat, as well as transportation. So 3 of the biggest causes of carbon emission in Germany. And municipal heat planning is, of course, focusing on the area of heat. It sets the rule for every single municipality in Germany to come up with a plan of how to achieve this goal by 2045. And to do that, there's a company called Digico, which is part of Westnetz and part of the E.ON group. And that's the customer that Alex and I have been working on for the past 2 years, I think, over 2 years. And they are active in this area. They offer many different products and services to support municipalities to come up with this plan. And one of which is called the heat concept. In essence, the heat concept, or in German it's called the Wärmekarte, is basically a simulation. So for every single building, it will simulate sort of the transition of how the building will be heating in the foreseeable future. So to do that, we used a data set consisting of about 21 million buildings, residential buildings in Germany, and included with some socio-economic data. So in the building data, you get all the characteristics of the building, like how high it is, how many floors, what's the floor space what's the renovation status. And in the socio-economic data, you have information about the inhabitants, how their affinity towards renewable energy, towards electric vehicles, and so on, and combined with heating data, which is how the building's being heated right now, what kind of heating technologies they have, how old is the boiler you might have, and as well as infrastructure data and zoning data on the municipality level. And with all this input, you can set then many different parameters that goes into the simulation model, including, so you can model the energy prices, how it's going to develop in the future. You can set the emissions based on how you predict the technological development will go for each technology. You can have the different costs, interest rates, subsidies, and so on. And you can create these scenarios. So for example, I expect the price of gas to be at this value in the future. And then I also expect the government to pass some law which will push for a specific renewable energy source. And all of this input goes into the simulation model, which will run and calculate for every single building how it's going to, like when it's going to change its heating technology, when it's going to renovate, and so on. And out of all this, the end user, the municipality, can get their aggregated results and see how much investment they need to make in order to achieve their planned goals. Now, all of this was already present, have been prototyped in Jupyter Notebooks. And while Jupyter Notebooks is a great tool, you can use it for fast prototyping of any algorithm, any sort of projects you want to make. However, it's not very well suited for a productive application. So this tool is supposed to use to support many different ongoing projects where each of them have their own customizations, each of them have their different sets of parameterizations, and it was just becoming too overwhelming to keep using this really prototype that were first built. Which is why this project came into existence, right? So to eliminate some of the issues we have dealt with Jupyter Notebooks, such as difficulty tracking changes. As you might know, all the cell outputs will get logged in Git together with the cell metadata, which makes it very difficult to compare the changes. And that leads into challenges with collaboration. It's sometimes difficult working as a group on the same project. It has some performance drawbacks because there's a little bit of overhead for running the notebooks. You have a lack of logging options. I mean, you can build everything yourself in the notebook, but it's just not as well supported as native Python applications. Documentation is another issue, as well as the needed technical knowledge. I guess to us developers, that might seem crazy, but people who are not well versed in Python might have some difficulty setting up the notebook, setting up the environments, and just getting things to run in the first place. Which is why the application was built. As for the technology stacks, of course, the core in the center, I guess it's a bit, cannot see it as well, it's Python. For the web framework, we chose FastAPI, which is a modern high-performance web application backend built in Python. Then Pydantic for data validation, anything to validate user input, internal data models. For the ORM, the standard SQL Alchemy. For logging, we chose Loguru. And for distributed asynchronous task execution, we use the package called Celery. We'll have some examples about these four main core stacks in a little bit. So for those of you, just as a teaser, Celery is kind of a Python package you can use to orchestrate and manage asynchronous task executions with your Python code. So you can send function calls as a task into a message queue, which will then be processed by your worker nodes. For the processing, because as you might imagine, we're dealing with building data, which involves geospatial data, so the actual geometries of the building. There are, of course, a lot more packages used for processing, but the main one, I guess, if you have to choose one, is GeoPandas, which is an extension or is a build on top of Pandas to support geospatial data as well. For visualization, we use Plotly as well as Matplotlib and the standard unit test framework for unit testing. And there's some supporting technologies like outside of the application. We have a front end built by another team in React. For authentication, authorization, we use Keycloak, which is an open source solution you can host by yourself. For monitoring, we use Sentry, which is kind of a SaaS tool because it was already implemented or adapted. And GitLab for CI/CD, so all the deployment pipelines is using GitLab CI/CD pipelines. For the database, we use Postgres because you can install an extension, a Postgres extension, which has strong support for geospatial data. There are alternatives, one of which is Snowflake. However, I think the support for geospatial data is not as rich as in the Postgres extension yet. So the standard, right, Docker and Kubernetes, of course, the application runs in a Docker container and is deployed into a Kubernetes cluster. And yeah, Azure Blob Storage for object-based storage option. And with that, I'll hand over to my colleague.
Thank you. So, yeah, thank you very much, Lynn. So let's have a deeper look into our architectural design. So which communications that are inside the applications, how all these services Lynn mentioned before communicate with each other, and yeah, what is happening inside the application. So as Lynn mentioned, every service that is not native Azure service is deployed and managed via the Azure Kubernetes services. So everything is containerized and yeah, more or less cloud agnostic to use, except for the few Azure specific services that we are using. So on the top, yeah, here as well. So we've got our front end that is communicating with our Python application. So the backend is more or less all around. And the communication that is going from front end to back end is mostly handled via Pydantic models or Pydantic schemas. So everything we expose to the outside via Swagger UI, Redoc, or some other kind of documentation is more or less schema validated through Pydantic. Then we've got our Keycloak identity and access management system on the top left in this chart. So Keycloak is actually doing all the authentication and authorization, and our application is just checking, hey, the user who is currently accessing some endpoint, does he or she have access to this endpoint or not? And we've got our database and blob storage services where we read and write our data, where the backend reads and writes the data. So we've got two databases. One is the data science database, which is more or less a company-wide database, which is used by several data scientists, as well as written by our application, by our backend. And the backend database is the database where all the data management and wrangling that is relevant for our application happens. So no other application has access to this database or should have access to this database, as it's critical for our backend to work properly. And finally, we've got our Azure Blob Storage. So all these three databases, the Postgres databases and the Blob Storage, are Azure services where we store and read our finished reports that got calculated. All the database accesses, as Lynn already mentioned, happen via SQL Alchemy, which we will look into more detail later on. So there is one major service left, which is Redis in conclusion with Celery. So Redis, for those of you who didn't heard of Redis, it's more or less, so it could be used as a cache for different services, but it's also a message broker. So Redis receives messages, and some other service tool can read messages from Redis. And this is how we use it, or at least how Celery uses it, as the asynchronous task processing unit, and we will get into more detail with this as well. So as said, we also have our Loguru and Sentry logging frameworks. So Loguru is doing the application internal logging, and Sentry is our logging interface, where we get notified if there are any exceptions or something like this. This is also very nice integration with Loguru and Sentry and Python overall. So when we get an exception, we can view which database accesses were made before, which API calls were made, and many more things to trace the exceptions and, best case, solve them rather fast. And now back to Celery. Celery is our heavy task load manager, which is calling our orchestrator. So that's the part on the right of the slide. Our orchestrator is more or less, so it's internally it's called scenario orchestrator because it's calculating scenarios, and it's built after the orchestration orchestrator design pattern. Which is more or less like you have one orchestrator in the middle and a lot of tasks or services around it. And the orchestrator is taking care of calling all the services around it. So in our case, we've got economic services, we've got new technology services, we've got heating change services. Each service itself is enclosed in itself and is calculating one important KPI or metric to do the municipal heat planning. And this is more or less so the overview of the most important tech stack that is used in nearly every FastRP. It is used in every FastRP application, I guess, in every or in most modern backend applications in Python where you provide some API to the outside. So FastRP is the routing framework, which just combines a lot of other frameworks, as we will look into it. SQL Alchemy for all the database stuff, and Pydantic for internal data management, for data modeling, and especially for validation and type safety, which is not common for Python. So yeah, so now let's get into a bit more details of the different tools we are using, starting with SQL Alchemy. So SQL Alchemy is an ORM, an object relational mapper. Hard word. Object relational mapper. And this means more or less that SQL Alchemy translates Python code into SQL statements in the end. It's trying to do this as performant as possible. And yeah, for us as developers, it's easier to write Python code instead of having big SQL queries that are hard to manage lying around. So with SQL Alchemy here on the right side, you can see you can, for example, define tables. You could add constraints. You could add indexing. And everything that is defined here in this code segment, so the different keys and values, they are not too important because it's just one example of our application. Everything you define here will then later, if configured correctly, which is just one line of code, will then later be built as SQL table in our database, in your database. And it doesn't matter to SQL Alchemy if it's PostgreSQL, MySQL, or whatever database, or Snowflake, for example, because you just need to update your driver in the background, but the ORM, all the selects and data table definitions that you have written, they stay the same. So yeah, as said, SQL Alchemy, you can define field types, descriptions, indexes, unique constraints, and many more. And one really cool feature of SQL Alchemy is the relationship definition. So you could define relationships between tables, which is usually in SQL done by joining the tables by some primary and foreign keys. But SQL Alchemy eases this for us to use. So we can define a relationship, in this case, between the scenario and the parameter table. So each parameter table has some scenarios assigned to it. And then when we query this, this table, the join in the background will be made automatically. So we don't need to write the join on this key is equals this foreign key and such. So SQL Alchemy takes care of this. And this makes developing a lot easier. And you can decide about this on a call-by-call base. So it's not like you build one relationship and then it's forever the relationship and you get a lot of data you don't need back. It's more like when you need it, you could do it and you make your life easier. And here we've got an example how an ORM or SQL Alchemy select could look like. So you just say select table name and .where, and then you put your where clause, and that's it. Quite convenient to use. And it's more or less comparable to a select star from table, in this case, where ID equals something. So next next library we'll look into is Pydantic. So it's the application internal pendant to SQL Alchemy. So here again, I've got our parameter schema or model, and Pydantic allows us to define names, and you see weird alias argument, for example. This is for the outside exposure. So our API has exposed keys to the outside, like title. And in this case, it doesn't make too much sense. But if you have something in Python with which is written in camel case, but you want to expose it in Python in snake case, but you want to expose it in camel case, then you could set the alias to camel case. So you can define different constraints like validators, like numbers need to be bigger than X and lower than Y. And this is all taken care by Pydantic. Pydantic also does some minor conversions. So if you expect some year variable that is an integer, but the input is like a string, but it's an int, so it's convertible to an int without issues. So Pydantic takes care of this, and the other way around, it's the same. But as soon as you violate some defined validations, Pydantic will raise an exception. It's also possible to write custom validators for harder topics to validate. If you, for example, have some custom things that I don't know, a number needs to start with 3 zeros and or a string needs to start with 3 zeros and then some random numbers behind it. Also, you could do this via a custom validator, which give you really great access over what is happening inside. And you don't need to care about validation anymore as soon as you have proper Pydantic validation in place. And in the last code snippets, so on the left, we see how our SQL Alchemy model, or SQL Alchemy schema, is passed into our Pydantic model. So SQL Alchemy is only relevant for the communication with the database, and everything else inside is done by Pydantic. And if we get some bad values from the database that are not allowed by our validators, which shouldn't happen as we have validated them before, the Pydantic would raise an exception. So now our last important tool for, at least for the API stuff, FastRP. So it's the core of our API. And it's quite easy to define some APIs endpoints with FastRP. You just give your decorator at app.post or something like this. And then you're actually set up. You need to write your code. You could also add your output models, which is also shown here. So in this case, it's a Pydantic model that is set as expected output. And FastRP will take care that we really send a parameter model, for example, to the outside. If there are any issues, there will be exceptions, but usually this shouldn't happen. And FastRP also takes care of the whole conversion. So most APIs respond with JSON, and FastRP doesn't care. So we give it our model, and FastRP takes care of the conversion. And no matter if we want to send XML, JSON, or something else, according to our definition, FastRP will send the correct format to the outside. FastRP also supports dependency injection, which is used in this case to gather user information and to get a database connection. And we've got out of the box Swagger UI and redoc documentation, so you don't need to care about this, which is also kind of nice. And this is also everything based on your schemas, on your Pydantic schemas you wrote earlier. And now as our last part, so Celery, which is our message and task processing tool for heavy load tasks. Celery is written in Python and is widely used in the community, especially when it comes to the why should you use Celery, for example, if you don't want to have some vendor logs or something like this. So if you all the cloud AWS, Azure, GCP have similar tools as salary, and maybe they are easier to set up as you don't need to take care of all the DevOps stuff. But in the end, you are dependent on the cloud. So if Azure raises their prices, you can't do that much against it. With salary, you don't have this issue, as you can Dockerize it, containerize, and you are the one who tells where it runs, more or less. Where could salary be used? Actually, in every application that needs asynchronous tasks. It also supports task scheduling and such, but mostly asynchronous tasks, heavy task loads, like backend applications as ours that need to be rather very responsive, but still calculate heavy tasks. And many more. So let's look into it, how salary actually works. Yeah. We've got said before, we've got our Redis, which is the message broker. So Redis is more or less the messenger who sends things from A to B. And we've got our producer. Producer is, in most cases, with salary, a Python application that produces messages. So let's say I want to calculate X. Then the producer sends a message to salary, hey, there is something to be calculated. And then we've got our consumer, which is consuming these messages from Redis, reading them, getting some additional information, which task to handle, which parameters we want to call, we have, and such, and then the task will be worked on. Salary also supports a limited number of tasks that get executed in parallel, for example. So you could say, I want to only calculate 3 tasks in parallel, and if there are 4 tasks in the queue, salary will take the first 3, and as soon as one task is finished, the next task will be grabbed and worked on. So this is also good to manage your workload or your server load. And don't pay hundreds and thousands of euros for some machines that are calculating 10,000 tasks at a time. So here we've got some source code examples for salary as well. So it's kind of easy. You need to have your decorator at task for your function you want to call, and when you're calling the function, you just call function.delay, and this tells salary, or this will send the message to Redis, and in the next step, your salary task will grab the message and will work on it. So from the deployment perspective, both of these, so the caller and the producer of the task, the producer and the consumer of the task could be in one application, but they also could be in different applications. This actually doesn't matter for salary as long as the Redis broker is the same, as otherwise, it wouldn't be possible to read a message when you don't know where it comes from. And with this, I'll let Lynn wrap all the things up and get us to the meeting.
Yeah, I promise this is the last slide to not keep you from the food any longer. So we thought, just as a summary, some lessons learned. I'm just going to skip through them. So the most important thing we've learned is project planning. Even in this case, it's a kind of migration project. You already have the requirements in place, how the application is supposed to operate, what's it going to output. You have to still do the proper planning, because things might seem similar, but when you actually work on it, you will identify all the differences. One of which performance optimization, because the idea is, once you have an application that is sort of client-facing or user-facing, even though the performance is the same as before, the expectation is different. So this is something maybe as the technical, like a developer, you might not think about because the code is the same, but as a product manager might care about that. And always focus on code quality and best practices. It will take time, but it will save you more time in the future when you need to refactor code, when you need to go back to the application after a few months of break, and just to have an idea of what the function is actually supposed to do. Things like data and I/O handling, which is not that relevant in the Jupyter Notebook because everything is sort of in the same directory. In actual application where the infrastructure is spread around different services, this becomes very important. How do you access data? How do you prevent services and endpoints from accessing data they're not supposed to? And of course, testing and debugging. I think many of you will be familiar with these things. Deployment is, of course, another new topic that wasn't present before. So think about how you want your application to be tested and build your deployment pipeline accordingly to fit in all the necessary testing in between your deployment steps. All right, then with that, thank you for listening. If you have any questions.
2 questions. Aha, that one was the first one. You, yes. Just say it, I will repeat it. Okay, my short repeating. Example, please.
Example for... Right, so no, this is not an automatic process, unfortunately. Right, so you have to look into what your notebook is doing, make your designs based on what it's supposed to achieve, identify sort of the technologies, like the technology stack that is needed, and then implement it. So find the parts that you can reuse, because you don't want to have as many changes, but yes, unfortunately. But I mean, nowadays with AI,
And question number 2 was somewhere here. Yes. Oh, this I can handle.
Just one question. Did you do this in one step, or did you made it one part of the, did you split it in parts and transform one part after the other?
So for this application, because it is a simulation, you had this clean separation between the individual steps. So yes, we did take into steps, like first take care of, for example, the data loader, and then the first calculation steps, and the results of which is passed to the next one. So in that aspect, yes, we did have some separations, but the whole project as a whole, well, because of project planning reasons, everything has to be done as quickly as possible. So many things were worked on in parallel. I think all of you are familiar with that. So.
Okay, if you have more questions, you probably will have to pay to Synvert and hire them, and then they answer, or use your break for this. Good. That was the last talk. So we owe a big thanks to our speakers. Now, to close this session, I will quickly recap the plan. Plan number 1, food over there. Yeah, I know there will be a line, I guess. So we'll have to be creative. Well, the good thing, though, food over there and bathroom over there. So we'll have 2 lines, most likely. Then the next meetup will be in January. It's already scheduled. We have a location, but we do need speakers. Please talk to me or talk to Eugen, talk to anyone, or just write us. Super introvert, just drop us a line on meetup.com. Then end of January conference, important, take a look. PyCon web, easy, or check it on my LinkedIn, like just put my name, I'm posting all of the announcements. This is a community event and it's a high risk event. So I ask for your support also as speakers and just to spread the word or to participate. Finally, yeah, please, orgs on the stage. Eugen, the cameraman, a very talented guy who is too shy to do announcements, but next time he will. Leon, come. Yeah, where are our speakers? 2 speakers are here, 2 more. Where? Two more. Come. You have to jump. We'll take one epic selfie, maybe. Maybe I'll take a selfie now. Then we also have Daniela. Who remembers Daniela? Anyone remembers Daniela? Good. So that was another coworker. She's a mother now, so she will be out for a while, but she's good. Please wave your hands. Come here. All right. Good. Then, thanks to you and thanks to our hosts, without you won't be happening. And now let's go get some food. Thank you very much.
Also, have one small joke. If someone worried about the quality of video, we just recording it on VHS camera.
Yeah, this is a retro style video feed. So, all right, I put some music. Let's go get that food. Music.
A де кушати?
Да. Іди покушай. Аж він прокинувся. Що, як справа?
Та нічого так.
What's up?
Nice meeting you.